Fine-resolution epithermal neutron detector. The fine-resolution epithermal neutron detector FREND is a neutron detector. This instrument is currently mapping hydrogen levels to a maximum depth of 1 m3ft3 in beneath the Martian surface, thus revealing shallow water ice distribution. This instrument has an improved resolution of 7.5 times over the one Russia contributed to NASA's 2001 Mars Odyssey orbiter. Overview. FREND can provide information while orbiting Mars on the presence of hydrogen in the form of water or hydrated minerals in the top 1 m3ft3 in of the Martian surface. Locations where hydrogen is found may indicate water ice deposits, which is one of the key ingredients for life. Mapping ground ice could also be useful for future resource utilization, ISRO and crewed missions. FREND also features a dosimeter to monitor the radiation environment along its orbit around Mars. Objectives. The main science objective of the instrument is to carry out high spatial resolution mapping of epithermal and fast neutron fluxes from the Martian surface. FREND will work in synergy and complement orbital and ground data, as measured the dynamic albedo of neutrons GAN instrument on the Curiosity rover, the ADRIN-RM instrument on the ExoMars rover, and the ADRIN-EM on the Kazakh. The second goal of FREND is to use its dosimeter to measure the radiation dose at the TGO orbit from energetic particles of galactic cosmic rays and solar flares. The data will be used to estimate exposure levels of spacecraft and maintain radiation safety of crewed interplanetary flights. Principle and development. Cosmic rays are sufficiently energetic to break apart atoms in the top 1 or 2 meters of Mars' surface, releasing high-energy neutrons, which can be measured by FREND instrument. The distribution of neutron velocities measured reveals the hydrogen content, which are a good indicator of hydrogen, abundance water, or hydrated minerals in the shallow subsurface of Mars. FREND uses inherited technology developed by the Russian Space Research Institute and flown on the high-energy neutron detector HEND on Mars Odyssey, the Mercury Gamma and Neutron Spectrometer MGNS on BP Colombo, the Lunar Exploration Neutron Detector LEND on the Lunar Reconnaissance Orbiter, and Dynamic Albedo of Neutrons DAN. This instrument's key components are 4 detectors containing helium-3 for neutrons with energies from 0.4 keV to 500 keV, and a stillbeam-based scintillator for high-energy neutrons up to 10 MeV. Each of the 4 3He detectors counts neutrons independently for increased reliability. All 5 detectors are encased within a collimator. The principal investigator is Igor G. Mitrofanov from the Russian Space Research Institute IKI. Mitrofanov is also the PI for ExoMars ADRIN-RM and ADRIN-EM neutron detector instruments.